Massive stars like the red supergiant Betelgeuse are destined to end their lives in spectacular explosions called supernovae. The recent discoveries made by the James Webb Space Telescope about Betelgeuse's unusual behavior have sparked fresh concerns and debates among scientists. Could this iconic star in Orion's constellation be on the brink of a supernova? And if so, what could this mean for Earth? The red giant on the verge of collapse. Betelgeuse, a colossal star approximately 700 light-years away, has been a familiar sight as Orion's shoulder. Its red hue, visible to the naked eye, signifies its status as a red supergiant nearing the end of its life. Stars like Betelgeuse exhaust their nuclear fuel, causing their cores to contract and outer layers to expand, often leading to fluctuations in brightness and size. In 2019 and 2020, Betelgeuse exhibited unexpected dimming, which some astronomers interpreted as a sign of its impending explosion. Others dismissed the idea, suggesting that the dimming was due to a massive surface ejection creating a dust cloud. Such disagreements underscore how complex and unpredictable stellar phenomena can be. How big is Betelgeuse? To understand the scale of Betelgeuse, consider this. If placed at the center of our solar system, it would extend beyond Jupiter's orbit. This star, about 1,000 times the size of the Sun, is thought to have expanded significantly over time as it burns through its nuclear fuel. The fusion process in Betelgeuse's core, converting hydrogen to helium and eventually heavier elements, has driven this expansion. Once the core's fuel is depleted, the star will collapse under its own gravity, potentially triggering a supernova. What makes Betelgeuse's behavior unusual? The star's 2019 dimming event was attributed to a massive ejection of material from its surface. This event created a dense dust cloud that obscured the star's light. While the Sun occasionally experiences coronal mass ejections, Betelgeuse's outburst was far more significant, potentially signaling instability. Scientists have also noted that Betelgeuse's brightness varies in two well-documented cycles. However, the 2019 event didn't align with these known patterns, leading some to speculate about an additional, longer cycle or an entirely new phase in its evolution. Could Betelgeuse be dangerous to Earth? When Betelgeuse eventually goes supernova, it will release an immense amount of energy, including radiation and particles. However, given its distance of approximately 700 light-years, the physical impact on Earth is expected to be minimal. While large particles from the explosion, such as fragments of stellar material, would not reach us, smaller particles like neutrinos, ghost-like particles that can travel vast distances, could arrive on Earth long before the light of the explosion does. Neutrinos are harmless but highlight our limited understanding of the full spectrum of particles and radiation that a supernova might produce. When will Betelgeuse explode? Predictions about Betelgeuse's timeline vary. Traditional estimates suggest it might explode within the next 1,000 to 100,000 years. However, a recent study by Japanese researchers proposes that Betelgeuse could be much closer to a supernova than previously thought. They interpret its erratic behavior as a sign of advanced core decay, a precursor to collapse. Once the star's core predominantly consists of iron, it can no longer sustain fusion reactions. Without the outward pressure from fusion, gravity will cause the core to collapse, leading to a supernova. What can we learn from Betelgeuse? Betelgeuse's eventual explosion will provide invaluable data to astronomers. Every supernova observed has unique characteristics, and studying a nearby supernova would help refine our understanding of stellar evolution and the physics of extreme events. However, the ongoing observations of Betelgeuse also highlight the limitations of current astrophysical models. The James Webb Space Telescope's discoveries have occasionally challenged established theories, emphasizing the need for continuous reevaluation of our understanding of the universe. Conclusion: Betelgeuse's fate captivates scientists and the public alike. Whether it explodes tomorrow or thousands of years from now, its story reminds us of the dynamic and unpredictable nature of the cosmos. As we watch and wait, advancements in astronomy promise to uncover even more about the life and death of stars, one of the most luminous stars visible to the naked eye in the constellation Orion, has long captivated astronomers and stargazers alike. Its distinctive red hue and prominent position in the night sky make it an iconic celestial body. However, its evolutionary journey is what truly holds scientific intrigue and fascination. A stellar giant. Located approximately 700 light-years from Earth, Betelgeuse is classified as a red supergiant, a massive star in the late stages of its life. Its immense size is almost unfathomable. If it were placed at the center of our solar system, its outer layers would engulf the orbits of Mercury, Venus, Earth, and Mars, stretching beyond even Jupiter. This extraordinary scale underscores the star's colossal mass compared to our Sun. But Betelgeuse wasn't always this enormous. Like all stars, it began its life as a dense cloud of gas and dust, igniting through the process of nuclear fusion. In its youth, hydrogen atoms fused into helium in its core, releasing energy that balanced the inward pull of gravity and sustained the star's luminosity. The consuming nature of fusion. Over millions of years, Betelgeuse burned through its hydrogen fuel. As the hydrogen supply dwindled, helium fusion took over, creating progressively heavier elements like carbon, oxygen, and silicon. However, each successive fusion stage generated less energy and lasted for shorter periods, destabilizing the star. Eventually, the core became primarily composed of inert helium, marking a turning point in Betelgeuse's life. Without sufficient energy from fusion to counteract gravitational forces, the core began to collapse. This triggered a sequence of events leading to Betelgeuse's ultimate demise, a supernova explosion. The supernova, a cosmic cataclysm. A supernova represents one of the most powerful events in the universe. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under its own gravity, unleashing an immense burst of energy. This creates a shockwave that tears through the outer layers of the star, ejecting them into space at extraordinary speeds. For a brief moment, the energy released by a supernova can outshine an entire galaxy, emitting more energy in minutes than the Sun will produce in its lifetime. The scattered remnants of such an explosion contribute to the cosmic cycle of matter, enriching interstellar space with heavy elements essential for the formation of new stars, planets, and even life itself. What remains? Neutron stars and black holes. The aftermath of a supernova depends on the mass of the original star. In Betelgeuse's case, its core could either collapse into a neutron star, a dense object so compact that a teaspoon of its material would weigh billions of tons, or if the remaining mass is sufficient, form a black hole. A black hole is a region of space with gravity so strong that not even light can escape. These remnants are of immense scientific interest, providing a unique laboratory for studying the extremes of physics. The future of Betelgeuse. Despite its fiery fate, Betelgeuse poses no threat to Earth. Its vast distance, 700 light-years, ensures that any radiation or debris from its supernova will not impact our planet. In fact, the light we observe from Betelgeuse today left the star centuries ago, meaning any explosion we see has already occurred in the distant past. Recent observations have shown fluctuations in Betelgeuse's brightness and surface activity, sparking speculation about an imminent explosion. However, such variations could also be caused by temporary phenomena within the star's complex atmosphere. Predicting the exact timing of a supernova remains one of the challenges of modern astronomy. Unlocking cosmic mysteries with advanced tools. The James Webb Space Telescope, the most advanced space observatory to date, holds promise for unraveling Betelgeuse's mysteries. Its cutting-edge technology will allow astronomers to study the star and other celestial phenomena in unprecedented detail, deepening our understanding of stellar evolution and the processes that govern the life and death of massive stars. A cultural and scientific beacon. Beyond its scientific importance, Betelgeuse has long held cultural and historical significance, inspiring myths and legends throughout human history. Its eventual supernova will mark a monumental event, offering humanity a front-row seat to a cosmic spectacle of unparalleled scale. This explosion will not only illuminate the night sky but also serve as a profound reminder of the universe's immense power, beauty, and interconnectedness. Betelgeuse's journey from its fiery birth to its impending supernova encapsulates the majesty and fragility of the cosmos. It challenges us to embrace the unknown and fuels our quest for knowledge, reminding us of our shared role as explorers of the universe.